Today is Wednesday, October the 21st. This is AP Chemistry. Welcome.
Hey.
Hey. Okay. Today's going to be a quick video because it's going to be predominantly a work day on all the AP questions that I posted in Classroom. Okay, so you can get a chance to practice. But today, first off, I want to go over the 2002 responses. We went over 2000 yesterday. We'll do 2002 today. Again, focusing on the wording. Okay? A lot of times we have a general understanding of the concept, but it's a challenge to get it down on paper with the right words. So we really want to focus on these, which is why I'm showing the actual AP scoring rubric so you can see the words that they use so you can learn to use those exact same words. Okay? That guarantees points. So, when we look at year 2002, it says, the atomic radius of lithium is larger than that of beryllium. Who would like to read your answer to that particular question? Go ahead.
Lithium has one less proton than beryllium, making beryllium have a higher nuclear charge and holding its electrons in more tightly. This causes its electron cloud to be smaller than that of beryllium.
Okay? Half right. Okay? Main concept correct.
Yeah.
Okay? What's missed? Anyone want to guess what's missing?
They're on the same energy level.
It's not even just same energy level, they're in the same sublevel. We need to always mention where the electrons are. Okay? Lithium and beryllium, both lithium and beryllium's electrons are in which sublevel? 2s. Okay? Are in the 2s sublevel. However, then we go into Uzma's answer. Beryllium has more protons, so that it holds the electron cloud in more tightly, making the electron harder to remove due to the increased nuclear charge. But you must include where the electrons are coming from. So if we look at the actual scoring rubric for this one, notice how they start out. Both lithium and beryllium have their outer electrons in the same shell, where they have the same number of inner core electrons shielding the valence electrons from the nucleus. I wouldn't get into the parenthesis part. Okay? Just the same, lithium and beryllium have their electrons in the same shell, and I would just say 2s sublevel. Okay? However, beryllium has 4 protons, lithium only has 3, therefore the effective nuclear charge, notice that they like to use that word, the effective nuclear charge, the experience, the attraction experience, how strongly the electron is pulled to the nucleus, however you say that. The experience by the valence electrons is greater in beryllium than lithium, so beryllium has smaller atomic radius. So the second part of yours, pretty much perfect. We just need to mention at the beginning that both electrons are in the same sublevel.
Do you always mention where the electrons are?
Anytime they're talking about ionization energy and comparing, you need to always mention where the electrons are coming from and then the strength of attraction, why there's a different strength of attraction. The strength of attraction here is more protons. But again, notice how they like to use the word effective nuclear charge. Okay? So, the next question is, explain why the second ionization energy of potassium is greater than that of calcium. Who wants to read? Go ahead, Carrie.
The second ionization energy of potassium is harder than that of calcium because potassium only has 1 valence electron while calcium has 2. It's harder to remove potassium's second electron because it's in a lower sublevel much closer to the nucleus.
Okay? again, I'd say 80% right. What does she need to say based upon what we just said?
There's
Ma'am?
more attraction when it's supposed to be.
No?
You need to mention that, the stable noble gas state.
Okay, because where are the electrons in that stable noble gas state?
The 3P's.
3p, no mention of which sublevels. Okay? So again, you can even use this diagram. Potassium has one electron out here in the 4s. Okay? So the second electron is removed, as Carrie said, from the closer energy level, but I would mention the 3p. Okay? So, again, the concept is 100% correct. We just want to make sure we use the right wording and include everything. So, when potassium's second electron is removed from the 3p sublevel, which is closer to the nucleus and more tightly held than calcium's second electron, which is removed from a 4s sublevel, which is farther from nucleus and less tightly held. Okay? So, just kind of always mention the sublevels. Let's see what AP said. Oh. Let's try this again. Okay? The second electron from potassium comes from the third level, okay, the 3p. Okay, the second electron removed from calcium comes from the fourth level. So we have to mention where it's coming from. The electrons in the third level are closer to the nucleus, so the attraction is much greater than for electrons in the fourth. Okay? Wording is very important. Very important. That's why I'm showing you just exactly what AP expects. And I've been a reader for 2 years, and I mean, it's a very narrow window. And sometimes I think I can read into it and I can say, I really believe the student knew what they were saying, but the table leader would overrule me because it wasn't saying it the right way. And they always took it and interpreted it as something completely different than what I'm interpreting it. So we got to use the key words. All right, next one. Oh, we didn't have to do the next one. We went to D. Is there a D? 2002. Where's that second page? Oh, it's on the back. I forgot. Two-sided. Okay? So the boiling point of chlorine is lower than the boiling point. So whenever you're dealing with boiling point, what do we have to deal with?
IMFs.
IMFs. Okay? Why not lattice energy?
But this is covalent.
It's not ionic, right? Lattice energy only applies to ionic. What type of compound? What elements are these? It's going to be they're covalently bonded, right? Okay? So what are my three IMFs? LDFs, dipole-dipole, hydrogen bonds. Okay? What type of these? Are they polar or non-polar?
Non-polar.
Non-polar, because their difference in electronegativity is going to be zero. They're going to have equal strength, equal pull for the electrons. Okay? So what's the only type of IMF?
LDF.
LDFs. Okay? With what do LDFs strength vary?
Electron cloud.
Size of the electron cloud. Which has the greater size of the electron cloud?
BR2.
Okay? Bromine, Br2. Okay, so we got to incorporate all that into an answer. Anyone want to read there? You already did one. Anybody else want to? Go ahead, Zane. Loud enough for everybody to hear.
Okay. Cl is smaller than Br because its electrons occupy lower energy levels, so they are closer to the nucleus and feel a stronger electric force from the nucleus. Consequently, Cl2 is smaller than Br2. Br2 has more electrons than Cl2, and since it is bigger, the Br2 London dispersion forces are greater than the Cl2 London dispersion forces. As a result, Br2 boils at a higher temperature because it takes more energy to break its IMF.
Okay? That's 100% right, except you don't need the first like 1 or 2 sentences. All about the electrons being closer. It's all just simply about the size of the electron cloud. Okay, you would get full credit for that, but the first part I would just have to ignore as a grader, as a reader. Okay? Both bromine and chlorine are nonpolar covalent molecular substitutes. Only IMF are weak LDFs. Because bromine has a larger electron cloud than chlorine, here's the key word. Bromine is more polarizable. Okay? More polarizable, causing it to have stronger LDFs and a higher boiling point. Watch the words that AP uses. Notice it mentions both are nonpolar and only have London forces. Okay? So you're identifying what the attractive force is. Okay? Since bromine has more electrons than chlorine, the valence electrons in bromine are more polarizable. The more polarizable the valence electrons, the greater the dispersion forces and the higher the boiling point. Super, super important. I mean, to be able to say it almost in those words. Okay, again, I think everybody understands the concepts. Okay, I think everything is clear on this. It's just a matter of you being comfortable enough and confident enough to be able to say it with the proper words. You get them in the right order. More polarizable, bigger electron cloud. That only applies to LDFs. The LDFs are the ones, bigger electron cloud, more polarizable. Dipole-dipole attractions, it's going to be all about the difference in electronegativity, how polar it is. And we have this thing called the dipole moment, which actually is a quantitative measure of a molecule's polarity. It puts a number on it. We're never going to calculate that, but if you're given the dipole moment, then you just kind of know the bigger the dipole moment, the more polar it is, the stronger the dipole-dipole attractions are going to be. And then we always have hydrogen bonds, which are the strongest of the 3 IMFs. Okay? So we just have to be comfortable with those thoughts. Okay? Does anybody have any questions on these? All right, so for the remaining time, 1 hour and 10 minutes, 70 minutes, 4,200 seconds. Okay?
Well, less now.
Yeah, less now. Less now.
Now.
Less now. You're going to work on the remaining questions. And again, just in your notes, make sure you're labeling each one, which year it is. And then I'll come by probably tomorrow and give you classwork credit for having those done. Most everybody was able to finish or get really close to being able to finish in first period. Okay?